Find the force in member AC in kilonewtons. In this problem, a truss of given dimensions is shown and subjected to a 5 kilonewton vertical load at point B. All members are rigid, and the wall connections include a pin connection at point A and a roller connection at point D. To begin, it is helpful to identify the forces at the connection points A and D. The connection at point A is a pin connection which supports a horizontal force F sub AX and a vertical force F sub AY. The connection at point D is a roller connection which only supports a horizontal force F sub DX. When solving static problems, two fundamental equations are the sum of the forces equals 0 and the sum of the moments equals 0. One approach to solving for the force in member AC is to sum the moments around point B, set the value equal to 0, and solve for the force in member AC. If we initially assume all members are in tension, the tensile force in member AC equals the tensile force in member AD times the length of member AB minus the tensile force in member CD times the length of member CD times the cosine of the angle theta, divided by the quantity the length of member BC times the cosine of the quantity 90 degrees minus theta minus phi. The unknown variables in this equation are the forces AD and CD, the length BC, and the angles theta and phi. The angles theta and phi can be solved using trigonometry. The vertical distance between points A and D equals 1 meter, and the horizontal distance between points B and C equals 1 meter. So angle phi equals the arctangent of 1 meter divided by 2 meters, or 26.6 degrees. Similarly, angle theta can be calculated as the arctangent of 1 meter divided by 1 meter, or 45.0 degrees. We'll next solve for the forces in members AD and CD. To do so, we'll isolate joint D, which includes the horizontal reaction force at point D, F sub dx, as well as the forces in members AD and CD, both initially assumed to be in tension. If we sum the forces in the y direction at joint D, we learn that the force in member AD equals 0. If we sum the forces in the x direction at joint D, and if we assume member CD is in compression rather than in tension, then the force arrow reverses directions and the compressive force in member CD equals the horizontal reaction force at point D. This reaction force can be determined by summing the moments around point A and setting the value equal to 0. The horizontal reaction force at point D equals 5 kilonewtons times 3 meters divided by 1 meter, which equals 15 kilonewtons. Since the horizontal reaction force at point D equals 15 kilonewtons, the compressive force in member CD equals 15 kilonewtons also. Of the unknown variables we began with, we've already determined the force in member AD equals 0 kilonewtons. The compressive force in member CD equals 15 kilonewtons, and the angles theta and phi equal 45.0 degrees and 26.6 degrees, respectively. The last unknown variable is the length of member BC. However, since the force in member AD equals 0, the first term in the numerator equals 0, and therefore the lengths of member BC can cancel out of the equation. The revised equation to solve for the tensile force in member AC is a function of the tensile force in member CD and the angles theta and phi. Since a negative tensile force is equal to a positive compressive force, we can make this substitution in the equation. After plugging in the known variables, the tensile force in member AC equals 11.18 kilonewtons. When reviewing the possible solutions, the answer is C.